On this Civic, P16E5 is a LIN communication fault between the PCM and the DC-DC converter. In plain terms, the PCM may not be getting the converter signal it expects over the LIN line. The vehicle may show electrical or charging system symptoms, warning lights, or it may not feel much different to the driver. The broad fault areas can include the LIN circuit, the ignition or power supply side, a connected component on that line, the DC-DC converter, or, after everything else checks good, the PCM. Start with the basic system checks and follow a structured diagnostic approach before diving into circuit testing. Next, check whether the related companion code is present. That decides which side of the diagnostic path you're on, but the target here stays P16E5. Then turn the vehicle to on mode and wait 10 seconds. Before disconnecting the PCM connector for this LIN and ignition cut relay circuit inspection, use the HDS to jump the SCS line and wait more than 1 minute. For the IG1 cut RLY and LIN, bat sensor circuit inspection, set up with the PCM connector A, the alternator 1P connector, the DC-DC converter connector A, and the 12-volt battery sensor connector disconnected. With IG mode on, the IG1ST CUT-RLY circuit should show 12V battery voltage. With IG mode OFF, the LIN, bat sensor, open wire check should show less than 1 ohmega. Then use the open or shorted circuit inspection method and check the LIN, bat sensor line for a short to ground with IG mode OFF. The normal result there is not shorted. Now review those external circuit results. If the inspection is abnormal, the problem is in the circuit, and if the power supply portion is abnormal, continue with the additional power supply checks to locate the failure. Don't jump ahead to a component call when the circuit result has already pointed you back into the wiring or supply side. Before the component connected inspection, again jump the SCS line with the HDS before disconnecting the PCM connector and wait more than 1 minute. This inspection is done with the external circuit already confirmed normal. Set up with the alternator 1P connector, PCM connector A, DC-DC converter connector A, and 12-volt battery sensor connector disconnected. Then reconnect the PCM, alternator, and 12-volt battery sensor connectors one at a time while checking the LIN, bat sensor circuit with IG mode OFF. The normal result is not shorted. If the circuit becomes abnormal when one component is reconnected, the problem is with the part that shorted the circuit at that point. This check can be useful early, but if it fails, you still have to isolate the failed item individually instead of guessing. For the DC-DC converter inspection, there is no direct test method for the converter itself in this path, so the diagnosis is done through the related components. Start this part only after the external circuit is normal. Run the confirmation procedure and check whether the related companion code is not indicated. In this diagnostic path, if that check is normal, the path points to a problem with the DC-DC converter. If it is abnormal, the path points back toward other related components. Next is the DC-DC converter circuit inspection, again with the external circuit normal. Prepare with the PCM connector A, alternator 1P connector, and 12-volt battery sensor connector disconnected. With IG mode OFF, the DC-DC converter internal circuit inspection should be not shorted. If that result is abnormal, the problem is with the DC-DC converter. If the other inspection items all show normal, the remaining call in this path is the PCM. The key is to prove the circuit and connected components in order before making that final decision. For more diagnostic training, visit stepdiagnostics.com.